We are already familiar with the standard form of a linear equation, as well as the function form or slope-intercept form. Today we're going to look at something called the model of direct variation. It states that two variables, x and y, vary directly if there is a non-zero number k such that the following is true. Y is equal to kx. Now, y is equal to kx is the model of direct variation, where k represents a constant. The graph of y is equal to kx is a line that's going to pass right through the origin, and the slope of this line is this constant k. So think back to, for just a moment, slope-intercept form of a line, which is y is equal to mx plus b. Well, if we said that the model of direct variation passes through the origin, well, that means b is 0. That leaves me with y is equal to mx plus 0, which we don't have to add. So we're going to see that this model of direct variation, y is equal to kx, is the same as y is equal to mx plus b, which is 0. So we see that k and m are the same. Slope, I kept saying, was a constant. K is a constant. Therefore, this is one and the same. The uniqueness about this is that this model will always pass through the origin. So when you go to graph this, that's where your first point will go. Let's explore a couple of examples. We're going to see a statement that says something like the variables x and y vary directly when x equals 4 and y equals 8. And they're going to ask us to find this constant of variation, k. So there's not a lot to go on here, except that we go to our model, y is equal to kx. We already have a value for x and a value for y. Let's replace them into the model. 8 is equal to k times 4. Well, in order to get the value of k, we just need to divide by 4. And we see that k is equal to 2. All right, so we've solved this. Find the value of k. K is equal to 2. Second thing, write the equation that relates x and y. How do I go about doing that? I go back to the model, y is equal to kx. And now I'm going to take that k and put it right into the model. What does that give me? Y is equal to 2x. And there's my model of direct variation. Y is equal to 2x. Now remember that it passes through the origin, so it's going to start, last thing tells me to graph, it's going to start at the origin. Well, if we know k is the constant, and k is also my slope, and we know slope is rise over run, we're going to go to this point and go up 2 and over 1. And then we're going to connect the points. The model of direct variation will always pass through the origin. So think about that for a moment. This is just another form. It's a unique one, and it tells me that these two variables are somehow directly related. And that means that we're going to take this x value, multiply it by a constant, and that's going to give us our y value. The variables x and y vary directly when. Those are the kind of questions or statements you're going to see when you're dealing with models of direct variation. We want to find the constant, we want to write the equation, and we want to graph. So let's do it all again. Model y is equal to kx. My y, be very careful, was 12 here. We're solving for k, and x is 3. One inverse operation will get me the value of k. K is equal to 4. What does the model look like? Replace k with 4, and there is your model of direct variation. Now the next thing we can do is obviously graph this. I'm going to just do a rough sketch on this one. I stop and I ask myself, well, how do I start graphing? Well, I'm going to start graphing at the origin because the y-intercept here is 0. So there is my first point. It's a positive slope. I'm counting up 1, 2, 3, 4, and over 1. And there is my graph. Now the very next thing they're going to ask you to do is to evaluate. Given a value, evaluate. Evaluate when x equals -2. So I'm going to go to my model, y is equal to 4x. I'm going to input that value of -2, and I'm going to find out that y is equal to -8. So you can use this model to evaluate at various points. We could look at one more example, and we're going to see once again that statement that x and y vary directly when x is equal to -5 and y is equal to 15. In the beginning, and you don't really have to do this, but I put the model down so you see that I'm replacing y with 15 and replacing k with -5. I do one inverse operation and I find that k is equal to a -3. My model now looks like y is equal to -3x. Graph on that one again, starting at the origin. I'm going to go down 1, 2, 3, and over 1, and there's my graph. I can evaluate this. I might say find the value of y. Let's say when x equals 4. So we're going to take my model, y is equal to -3 times x, replace x with 4, and I'll find out that when I input 4, my output is -12. Gives me another reference point on my graph. We're going to do more, and actually since we had a quiz today, I'm going to ask you just to watch this video and maybe write down 1 or 2 things that you learned today, or perhaps let me know if you've ever worked with the model of direct variation before.